Hi everyone. In this video, we're going to start some talk about, I say angles and circles, but really it's about angle measure and specifically measuring angles using radians. So generally people are fairly comfortable with degree measure, and we will go over that at the end of the quarter when we're working on right triangles. I like to save some of the easier, more comfortable stuff for the end of the quarter so we get a little break. But I really want to focus on radians and not worry too much about switching back and forth early on in the quarter. Okay, so radian measure. I happen to have a PowerPoint made up for this for face-to-face classes because there's a fair amount of wordy stuff and not that much work that happens. So the slides are posted in WAMAP, and I'm just going to flip through and use them because they're prettier than my usual type thing. Okay, so angle. We want to picture this as we take some ray, so a line segment with an endpoint is what I'm picturing here. So it goes off forever one direction. Endpoint, I'm just going to call this P for now. We rotate the ray about its endpoint. So we leave point P fixed and we rotate the ray around, and that traps this little angle. Let's just say that's the direction we went. So this is my angle. I'm going to go ahead and call it theta. It's really common to use Greek alphabet letters. So you'll see theta, and you'll see alpha, and you'll see beta, and you'll see gamma this quarter. You don't have to use them, but they are really common to see in trig. If you would like, in WAMAP, I've linked Greek alphabet, so you can check them all out. Not required, but it is in there in Exam 1 materials at the bottom. Okay, what else do I want to say? So if we rotate counterclockwise, is that what I want to do first? Yes, counterclockwise, we get a positive angle. So this one is in fact positive. We could also rotate clockwise, and that would give us a negative angle. So if we started here and we rotated, we'll just make this one little this way, that would be negative. So there is a direction associated with our angles. Again, counterclockwise is going to be a positive angle, and clockwise is going to be a negative angle. We're going to get even a little pickier than this. So these are great. These are angles, but we like to look at a lot this quarter in standard position. So standard position just means we superimpose a Cartesian coordinate system. So this is just our usual x-axis, y-axis, and we put our angle in this coordinate system where we use the x-axis for the initial side. I guess I should label this up above as well. So with any of these, we always have an initial side where the ray starts, and we have a terminal side where the ray ends. Terminal. There we go. Okay, so we would place our initial side along the positive x-axis. So starting from the origin, point P is now the origin. And then we would say, just like we said before, if we spin up, so if we go counterclockwise, we get a positive angle, and if we go clockwise, we get a negative angle. So that's going to be standard position. So this one up above, if I can just sort of eyeball it, say we took this angle and just transferred it down here, maybe it looks about like that. This could be the exact same angle, just drawn in a different position. So you can draw them in any position. We will try and get in the habit of looking at a lot of angles in standard position, just so that we're all looking at the same thing. Okay, let's see what else. I think I do actually want to point out one more thing on this one before I move on. Some notations you'll run into. We won't see a lot of these until later in the quarter, but you can refer to an angle by giving it a variable name theta. You can also just refer to an angle by naming the endpoint, and in context we'll figure out you mean the angle that's at P. So this angle theta, I could also just say P, or if you want to be really specific, you can say angle P. If you put that little guy right there, that means angle. Sometimes, try not to forget any, we'll get more specific. We won't have our rays go on forever, so we might have something like here, A, B, C. We can label all 3 points, or we might even get a triangle. We'll do that as well. And in this case, you could say angle ABC. That seems really messy, but what's nice about it is it tells you what order. So AB is your initial side and BC is your terminal side. So we're looking at that angle right there. Not to be confused with BCA, which would be this top angle. Okay, so little notation stuff as well. This is just kind of our getting going on angles. Okay, what is this one? Coterminal. We don't actually worry about this a ton, but the thinking behind this, we will use all quarter long. It will just hopefully become second nature. However, I think it's really nice to have this as we're learning just basic stuff about radian measure. It lets me ask you some good questions to think about angles measured with radians. So we've talked about the fact that we get an initial side and a terminal side, which at least they are very conveniently named in ways that I think should put us on the right track with what they're referring to. There is more than one way to rotate a ray and end up with the same final direction, the same terminal side. So this is the exact same initial and terminal side, but I did not get there in the exact same way. So for this first one, I just have this small negative angle. An acute negative angle. Acute angles are those little guys, less than 90 degrees. I could also do a fairly big, or comparatively big, positive angle. I could even go round and round and round a little bit either direction. So in this one, I started and I went one full time around, and then far enough to get back to that same terminal side. So these 3 angles are definitely not the same angle. I had to use an entirely different path to get there, or at least partially different path, but they are coterminal. They have the exact same initial and terminal sides. So the rotation is different, but the initial and terminal sides are the same. Okay, I think I'll quit there, make a separate video for getting into the radians. Thanks for watching.